Okay, class, what I'd like to do is go over this test review so we can kind of show you what it is I'm expecting out of you. So in this first one, we've got 10x plus 5 equals 35. Well, we know in every single equation, we've got three basic steps that we've talked about over the last few days. Okay, that is, one, get all your letters on one side. Okay, get all your numbers on the other side. And the way we do those two steps is we always add the opposite. And then the last step is to solve. And in that step, we do the opposite. So when we look at this first one here, we've got 10x plus 5 equals 35. So I need to move this 5 over to be with the 35 because our letters are already gathered together on the left-hand side of the equal sign. So I'm going to move the 5 to the other side by adding its opposite. So 10x plus 5 plus the opposite equals 35. And if I add the opposite to one side, I've got to add the opposite to the other as well. So we end up with 10x is equal to, and 35 plus negative 5 is 30. So now I need to get the x by itself. So I divide both sides by 10, and we get x equaling 3. So that's how we answer the first question. Well, the second question, you'll notice we have a minus in here. Well, you know how I feel about minus problems. I'm going to change subtraction to addition and the next number to its opposite. And then I'm going to do exactly what I did on the previous problem. I'm going to move this negative 9 over to be with the 15 so I can get this 6a to be by itself because the letters are all gathered together on the left-hand side. So I need my numbers on the right. So we have 6a plus negative 9 plus the opposite of negative 9, which is 9, equals 15 plus 9. So now the 9's go away and I'm left with 6a equals 15 and 9 actually make 24. So now to reverse a multiply by 6, we do a divide by 6, and we end up with a equaling 4. Now on 3 and 4, both of these are kind of some unique situations where we have division, or we have a multiply by a fraction. So we need to understand how to do each of those as well. So in number 3 here, we start again with a minus. I'm going to change subtraction to addition, and the 13 to its opposite, which is negative. And now I begin this question exactly like I did the previous two. I get rid of the negative 13. So we end up with d over 5 plus negative 13 plus the opposite of that, which is equal to 3 plus the 13, which I added to the left-hand side. So again, my 13s add out and make a 0. So we end up with d over 5, which is equal to 16. Now to get rid of a divide by 5, what we do is we do a multiply by 5. And if I multiply one side by 5, I multiply the other side by 5 as well. So this 5, which is kind of like on top as a numerator, will divide out with this 5 on bottom, which is in the denominator, to make 1. So we end up with 1d, or just d, equals, and then we do 16 times 5, which is 80. Now in number 4, we do exactly the same thing. We start off by getting rid of the plus 7. So we have 1/4 w plus 7 plus negative 7, which is equal to negative 4 plus negative 7. So our 7's add out, and we end up with 1/4 w, which is equal to negative 7, 8, 9, 10, 11. Now to get rid of a 1/4, well, we have a multiply by 1/4. So what we do is we divide by 1/4. But we know in division of fractions, we always multiply by its reciprocal. So to get rid of this 1/4, really, I multiply by 4 over 1. So on the other side, we multiply by what 4 over 1 really is, which is just 4. So these divide out and become 1w, which is equal to negative 44. And that's how you solve the first 4 questions. And each of those are two-step equations. So let's move to what we've been working on the last couple of days. What if I have variables on both sides of the equation? Well, this is where we have those 3 steps. Step number 1, get all your letters on one side. Step number 2, get all your numbers on the other side. Step number 3, solve. Well, the first thing I'm going to do here is I'm going to change the subtraction to addition, the 18 to a negative, and then I'm going to get all my letters on one side. Now, most people like to have their letters on the left, so I'm going to start by moving this 4b over to be with this 8b. So I'm actually going to start on the right-hand side of the problem. 4b plus negative 4b plus negative 18. And I'm going to add this negative 4b on the other side as well. So we end up with 8b plus negative 4b plus the 2 that comes along for the ride. So my 8b and my negative 4b actually make 4b plus 2, which is equal to, well, over here my 4b's go away, and I'm left with negative 18. So now I need to move my 2 to be with the negative 18. So 4b plus 2 plus negative 2 is equal to negative 18 plus negative 2. So that will give me 4b equaling negative 20. So now if I divide both sides by 4, you end up with b equaling negative 5. Now I know I wrote that off to the side, but I was running out of room and I didn't want to write into the other problem. Okay, so what about number 6? And number 6, what you need to look at on this one is we've got several things going on in this problem. But on 6, we've got 7w plus 6 on the left side. But on the right side, I've got 2w plus 7 plus 5w. So I actually have two w's here that I could actually put together. So we end up with 7w plus 6, which is equal to, now the 2w and the 5w also make 7w plus 7. Now this is one of those kinds of problems where I told you that if the same letter combination is on both sides, they're going to subtract out. So if I were to move this 7w over to the left-hand side, what really happens is I'm going to write 7w plus negative 7w plus 7. So on the other side, I've got 7w plus the negative 7w I just added on this side plus 6. And you find out that both 7w's go away. And we're left with 6 is equal to 7. So this is one of the instances where your letters will be eliminated, your variables will go away, and you're left with a statement, 6 equals 7. And we know that statement is not true. So what you do is you put a slash through the equal sign saying that it's not equal, and you write no solution. Because that's the answer to the problem. There is no value I could plug into these w's to make this equation true. Well, number 7. In this one, the first thing I'm going to do is I'm going to change this subtraction to addition next to its opposite. And I see that I can simplify some stuff here. The 8 and the 4 I could actually put together. So we end up with 8h plus, well, negative 8 plus positive 4 gives me a negative 4, which is equal to, on the other side, I just leave it alone. Okay, and I end up with negative 4 plus h, 8h. Now you'll notice that those are both equivalent statements. So again, my 8h and my 8h, if I were to add the opposite on both sides, it's going to be eliminated just like it did up here in the 7w's. So we end up with a statement that says negative 4 equals negative 4. Well, unlike question 6, this statement on number 6 was not true. But on question number 7, this statement is true. So what you write for your answer is all real numbers. Because every number that I put into h will work in that scenario. Okay, so that's what you're going to be tested on tomorrow that deals with equations. Now I decided to throw in one more set of things that deal with all that stuff we did in Unit 1. Okay, so here are two questions that deal with comparing and ordering. So number 8 says, which list shows numbers in descending order? Well, descending means that things are going down. So it's going to be orders from greatest to least. That was one of our vocabulary words last week. So if we look at our answer choices here, one of the things that you might want to do is get a calculator out to answer these questions. Okay, so I'm not going to do that on this particular one, but that's what you do. Okay, so we look at A right here. We got negative 3.8 or 3.28, negative 3.47, 8, and 14. Now if we're going from greatest to least, we know that we cannot start with negative numbers unless all of the numbers are negative. So A could be eliminated. Now if we look at B, we know the value of 18 is just 18. Well, the value of the square root of 21 is approximately 4.5 if you were to type that into the calculator. We know 1/2 is 0.5, and then we have negative 4.82. So if you look at that and look at it on a number line, we have 18, then 4.5, then 0.5, and then a negative number. That tells us that this one is definitely in descending order. Now if we look at C, the square root of 9 is 3. 17 over 2 is going to be, I believe that is 8.5. 7 3/8 would be 7.375. And then 21% is going to be 0.21. Well, the descending order part, it's messed up right here at the beginning. So we know that one's not going to work. Okay, same thing would hold true for this last one. If you put this 33 1/3%, that's the same thing as 0.3 with a bar. And I know 40.5 is bigger than 0.3 with a bar. It's also bigger than 8 3/4. So I know that one's not it. Okay, so when you have different forms, please make sure that you use your calculator to change them all into decimals and then do your comparison. Number 9, Fred orders a set of numbers on his homework, or orders a set of numbers on his homework in ascending order. Okay, so ascending is the opposite of descending, so this one's going to be least to greatest. The first number is 5 1/3, and the last number is 5 1/2. Which of the following numbers is not in Fred's list? So what I'm looking for is which one of these numbers is found in between there, okay? And the answer is going to be the one that is not in between there. So we know 5 1/3 is actually 5.3 with a bar, and I know 5 1/2 is 5.5. So I'm looking for values that are between 5.3333333 and 5.5. Well, I know A, the square root of 25, is 5. We got 5.45, 5 3/4, and 5 5/12, which is going to be about 5.4 something. Okay, because 5 is just under half of 12. So this one, it's in between there. 5.34, that's in between there, just barely, but it is. And this one's going to be just under 5 1/2, so it is. So the only one that's not in between those is the square root of 25, which is 5. Number 10, the surface area of the Earth is 5.101 times 10 to the 8th square kilometers. What is that number in standard form? Well, we need to remember that this 10 times 10 to the 8th says move the decimal 8 places to the right. So if we were to write 5.101 and I move my decimal 8 places, it's going to go 1, 2, 3 places around the original numbers, and then 4, 5, 6, 7, 8. So that means I'm going to add some zeros into this number right here, because any empty places we add zeros. And now we can't leave our number written with these little humpy bumpy things on it. We've got to actually write it clean. So this is 5101 0 0 0 0 0. Come back and place our commas. That's 510,100,000. Number 11, the set of irrational numbers includes all of the following except. Okay, irrational numbers. That's one of the definitions that we have to know. An irrational number is any number that can be, when we write it as a decimal, will be a non-terminating, it doesn't stop, and it doesn't repeat, non-repeating decimal. Okay, so when we look at pi is the most famous irrational number. It is the most famous irrational number, so it is irrational. Sorry for that noise there, my phone was going off. Okay, B. We've got 0.45, 455, 4555. The next one would then be 45555. Now there is a pattern to this number, but it does not repeat. The repeating would be 0.4545454545. So this one is also irrational. Okay. D, if you type in the square root of 124, you're going to get a fairly ugly number. Okay, so this one right here, this is going to be a little bit over 11. Okay, 11 point something. So this one is also an irrational number. And if you type in the square root of 169, you're going to get the number 13. Okay, so the set of irrational numbers includes all of the following except C is the one that is the exception, because that one's going to be a rational number. Number 12, the diagram below shows the side of a ramp used to help load and unload a moving van. Which measurement is closest to the length of the ramp in feet? So we've got a right triangle. So we've got this leg and this leg right here. So these are our two legs. So in the Pythagorean Theorem, it's the a squared and the b squared. And I'm looking for C. Okay, so what we do is we write the formula. A squared plus b squared equals c squared using the Pythagorean Theorem. We plug in the 3 for the a squared. We plug in the 9 for the b squared. and we're looking for c squared. So we do our math. We end up with 9 plus 81 equals c squared. So we add those together to get 90 is equal to c squared. So what we do in order to get c squared into c, we take the square root of 90, and that's going to give me, if we actually do the math, you end up with something around 9.48 in a bunch. Okay, so 9.48 actually gives you an answer around A. And again, you take the square root of 90 on our calculator. So that's how we actually work each of the questions on our test review. So I hope this helps. Good luck on your test tomorrow.